The last thing we're going to be covering is asynchronous JavaScript. So far, the only limiting factor to how quickly all the code that we've been writing can execute is just how fast our processor is. If we wanted to calculate 1,000 prime numbers, right, the only limitation would be how quickly our processor can process all that code. But in the real world, the limiting factor for how quickly your code can execute is very often going to be how quickly something can travel over the internet, not how quickly it can be processed once you get it. For instance, you can imagine if we were fetching a bunch of data from our database, it might only take us, half a millisecond to process it, but it might take several milliseconds for that data to get to our machine from wherever our database is. So don't worry about how these functions work, but here I have written two functions which return the base experience of Pikachu and Charizard from an external API. What would happen if I try and just log this experience? Get base Pikachu XP, and we can also just log get Charizard XP. Get Charizard base XP. Say bun async.js. And this is what we get. We get two promises that say they're pending. So what does this mean? What this means is all we have said is we want to get the result of this get base Pikachu XP. But JavaScript does not want to immediately assume that we want to stop everything we're doing and wait for the result before doing something with it. For instance, right, we might want to start fetching both of these, start fetching the Pikachu base XP and the Charizard XP, and let those both, let both of those requests go through before we need to do anything with them. If we want to take this asynchronous code, which is going to go over the internet, it's going to take some time before we get the results back, and we want to say, hey, JavaScript, I want you to stop what you're doing and wait until we have the actual result. What we need to do is we need to use the await keyword. Await. And you know that you will need to use await on a function if it's marked as an async function. So now I can run this, and it's going to take a second because I added an artificial delay, but then we actually wait for the value, right? You can also get a little bit of IntelliSense from your, from VS Code. So we can say const Pikachu promise equals get Pikachu base XP. This is going to be a promise type, which is going to return something from that promise. And then we can say the actual XP, actual XP value equals await Pikachu promise. And now it's not going to be wrapped in a promise, it's just going to have that actual value. And then we could log it and wait for that to go, and we get our value. So you can already see the situation where it makes sense that sometimes we don't want to immediately await the value of a promise. Very often you're going to start a function and you're going to need, 3 different database calls or 3 different pieces of data to actually process the thing you're trying to process. It doesn't make sense to sequentially say, hey, get the first piece of data, wait until I have the first piece of data. Get the second piece of data, wait until I have the second piece of data. Get the third piece of data, wait until I have the third piece of data. Instead, it makes more sense to say, hey, get me pieces 1, 2, and 3 of data, and then wait until I have all three of them, and then I can do my processing. So we can actually see what this looks like, right? Before we had, we were first awaiting the Pikachu base XP and then awaiting the Charizard base XP, right? But what we can do is we can say const Pikachu promise equals get Pikachu base XP, const Charizard promise equals get Charizard base XP, and then say, hey, await Pikachu promise, await Charizard promise. So pay attention to when the things are logged. Wait, wait, wait. Now we have both pieces of data, right? They take about the same amount of time, so it makes much more sense. It's about twice as quick to say, hey, here is all the information that we need, and then once we're actually trying to process it, then we await it and go on to then use the information. Key syntax to remember is any function that is marked with async will return data wrapped in a promise. It means that, hey, it doesn't matter how fast your computer is, there's going to be some external thing, some external fetch that we're going to have to wait for. And then when you actually want that information, when you want to say, hey, stop executing code because I need this information before I can go any further, you say await whatever that result is. The other thing that goes hand in hand with asynchronous code is error handling. Most of the time when all of the code execution is on your own machine and you don't have to worry about some network connection or some external service, you can normally predict when you're likely to have to encounter errors, how you're going to have to handle them. But anytime you're dealing with some external API, you have to properly handle errors. For instance, if I were to not execute, change anything about the code, and just turn my Wi-Fi off, and if I were to try and run this, I'm going to get an error, right? Either there was a typo in the URL or it couldn't establish the connection, and this is not going to work how I want. For this, you use something called a try-catch statement. Try-catch statement just says, hey, here's some code that I want to attempt to execute, and then if any error is thrown, here's the code I'll execute instead. All you do is you say try, and then you can wrap whatever you want to try. Oops. And then you say, catch. You'll get some error object, and you can do something with it, right? You can console.log your error. And then we can live to code another day, say, hey, this will still execute. We actually only need one of these, and what we expect is that we will run into an error because we have no Wi-Fi, and then log the error, and then continue to execute the rest of our program. So if we run that, we say there was an error, this was the error, and then this will still execute. Then if we were to delete this try-catch, and try and make sure that we have this will still execute running, we won't get there because it will error beforehand. we actually only need one of these, and what we expect is that we will run into an error because we have no Wi-Fi, and then log the error, and then continue to execute the rest of our program. So if we run that, we say there was an error, this was the error, and then this will still execute. Then if we were to delete this try catch and try and make sure that we have this will still execute running, we won't get there because it will error beforehand. One final useful bit of syntax before our final challenge is if you have a lot of promises, perhaps they're all in an array, and you need to await all of them at once, there's some nice syntax you can do for that. So what we could do is we could refactor this, say const Pokemon promises equals an array which has get Pikachu XP and also get Charizard XP. And let's say I wanted to await both of the promises and then sum them. I could say const Pokemon values equals await promise dot all, and then we pass in that array. This is going to have our two values at the 0th and 1st index of the array. And then if we wanted to console.log, we could say the total XP is Pokemon values 0 plus Pokemon values 1. And if I reconnect to the internet and run this, we will get our total XP and this will still execute. Now we're ready for final challenge of the video, which is write an async function that takes a name of a Pokemon and returns the base experience. If the Pokemon is not found, return Pokemon not found. So for this, you can copy this internal code from these functions and just refactor it such that instead of saying Charizard, it's the actual Pokemon name. And a little hint is that if the Pokemon is not found, then this little segment of code will throw an error. So you can wrap it in a try catch statement to handle the case where the Pokemon is not found and return Pokemon not found. Give you a second to pause the video and try it yourself, and then we'll do it. So what we can do is we can say const get Pokemon XP takes a name, we'll say a Pokemon name. Then we can paste that code segment. You'll notice, right, it's bugging us because we need to make sure that we specify that since we're using asynchronous code, we need to mark this function as asynchronous. All we need to do is, instead of passing in Charizard, rewrite this so that it takes the Pokemon name, and that will return the experience like we want. We can test this out, say console.log get Pokemon XP for Eevee. Sorry for the dogs in the background. run this. Oh, gotta await it. 65, but this doesn't handle errors. So to make it handle the error properly, we need to wrap it in a try catch statement and return Pokemon not found. So then, even if we have bad spelling, we will not error. We will simply say Pokemon not found. And there you go. That is your crash course on basic JavaScript concepts. As a reminder, all of the completed lecture code, it might not be 100% the same as what I wrote, but all of the examples are in the completed folder, and we have the blank folder for you to follow along, which hopefully you are doing. Next week, we're going to cover TypeScript, which adds functionality on top of JavaScript to make it much, much easier to write and maintain. See you then.